Hi everyone, hope you had a good weekend. We're going to get started this week with finding area of a shaded region. And what's nice about this lesson is it really is nothing new in terms of formulas or ideas. It's just a matter of kind of rethinking how we look at a problem. So how do we find the area of a shaded region? Well, here's a typical area of a shaded region type question. Right here, you'd be given something like this. And there are two methods to find the area of a shaded region. The first method is known as dissection. So we've talked about that before, like when dealing with a trapezoid. We're basically working to just break that shaded region up into smaller polygons that we're familiar with, like rectangles, squares, triangles, etc. The second way is known as this formula. Basically, in order to find the area of the shaded region, you find the area of the larger figure and take away from it the area of the smaller figure, which right now that kind of seems probably confusing. Like, what do you mean smaller and larger? But I'm going to do an example and show you what I mean by that. So let's take a look at what we have here. First way we're going to show you this is by dissection. So you'd be given this problem and it would just say find the area of the shaded region. So if I were to break this figure up into polygons that I'm familiar with, I see this over here. So this becomes this. And take a look at what I have. I have four small rectangles, right? I kind of dropped down a vertical line here and a vertical line here. So when you do this, you want to be able to draw in like auxiliary lines, essentially helping lines, to divide the bigger shape, the shaded region, into smaller polygons in which then you can find the area of. So if I take a look at this right here, I have a rectangle, right? And it's rectangle A. What I knew at first was that this full length was 12 and that this length from here to here is 8. So in order to find this length, this little piece of my rectangle, which also matches down here, what I had to do was take the two measurements, 12 and 8, and subtract them, and then find their difference, which is 4. And I knew, okay, well, that means that this piece and this piece must sum to 4. So I take 4 divided by 2, which gives us 2. So each of these pieces here and here are 2. So I kind of put them down at the bottom, 2 and 2. Now notice, rectangle A and rectangle B are identical. And it just so happened to be that way for this problem, which is nice. So right off the bat, I know how to find the area of A and B. They're both rectangles. So it's going to follow base times height, 2 times 5, to give us an area of 10 centimeters squared. Now, to find C and D, what I have to do is look vertically up and down. And I see that they gave us that this full length was 5. So from here to here is 5. Okay, excellent. And then this tiny in the middle, this length, this piece is 3. So same idea. 5 minus 3 gives us 2. That's left to split between here and here. So 2 divided by 2 is, in fact, 1. So now I know that this rectangle is 8 by 1, which matches this rectangle at C, which is also 8 by 1. So the area of C and D, base times height again, 8 times 1 gives us 8 centimeters squared. So now, in total, how many rectangles do we have? 4. We have rectangle A, rectangle B, rectangle C, and rectangle D. So I took all of the areas. A and B we said were 10 centimeters, right? 10 and 10. And then C and D were 8 centimeters, so 8 and 8. Add everything up, we have 20 plus 16 gives us 36 centimeters squared. Okay, so that's using dissection, taking the shaded region and breaking it up into smaller familiar shapes like these rectangles. If we're going to use that whole idea of that the area of the shaded region is equal to the larger figure minus the smaller figure, we're not going to break it apart. We're going to look at it kind of as a whole picture. So what do you see here? And I mean, when I look at this, I see a big rectangle with a small rectangle missing in the middle. So my larger figure is a rectangle. And here it is. This is my larger figure, this rectangle right here in blue. Okay. So if I found the area of that big rectangle and then took away this small rectangle, I'd be left with just the shaded region. So that's what we're going to do. Area of the big rectangle is 12 times 5, So base times height gives us 60 centimeters squared. And then our small rectangle is in the middle. Here it is. That's 8 by 3. So to find the area of that, we do 8 times 3, which is 24. So to find the shaded region, I just subtract 60 and 24 right here to give us 36 centimeters squared. The same answer we got by dissection, 36 centimeters squared. Okay, so like a lot of the other lessons, 2 ways to get to the same answer. It's really whatever you feel the most comfortable with. I'm not always consistent in always doing larger figure minus smaller figure. Sometimes dissection works. I just kind of look at the picture and ask myself, what do I see? If it's easier for me to break up a shape, I use dissection. If it's easier for me to take something out from something big, I use the area of the larger minus the area of the smaller. All right, so let's go on to just take a look at a few practice questions. And now we kind of threw in a little curveball to you guys. So what you're going to do this week is with every lesson, you're going to have the worksheet. I'm going to go through the solutions, but what's new is we're going to pick 1 or 2 questions that you'll be submitting your answer on the Google Forms. Now, you're not getting graded, right? So no grades. It's just kind of for feedback. I'm just curious. You guys can follow along with me. It's usually easy when the answer is right there in front of you. But what if I gave you a question to try by yourself? So for this first question, I'm going to ask you to try this by yourself, right? So either use dissection or a larger figure minus smaller figure. Do your work on here or on a separate sheet of paper, and then after you're done watching the video, there's going to be a link. You're going to click the link, fill in your name and your answer, and there's going to be a solution attached to your submission. So take a look for that. So let's try number 2 then. Let's find the area of this shaded region. Now for this, what I see this as is this big rectangle with like a triangle cut out. Maybe you see it differently, but that's how I see it. So I'm going to do area of the rectangle minus area of the triangle, because the rectangle is the bigger figure, triangle is the smaller figure. So my rectangle is 12 by 4. So I'm going to do 12 times 4, which is 48, right? And then my triangle, which is here, is 9 centimeters as the base. And now the height, remember the altitude goes from the vertex perpendicular to the base. Now this wasn't labeled, but I know that this altitude is actually also parallel to the side of the rectangle, right? If this is the height of the rectangle, it's the height all the way through to right here. So my base is 9 and my height is 4. So 9 times 4 is 36. 36 divided by 2 is 18. So to find the area, I'm going to do the rectangle minus the triangle, and we're left with 30 centimeters squared. Not too bad. Hope that you think that this is kind of getting a little bit easier, or at least you're able to recognize what it is that we're doing. Okay, so now let's take a look at number 3. So what do we have going on here? I like this question because it's interesting. I'm going to do this by dissection. Now you can certainly do this by doing area of the big minus area of the small, but I like to kind of switch it up to give you guys a taste of both here. So dissection. So what do we have going on here? I broke this like plus sign into 5 shapes, okay? So I have 4 rectangles, and my rectangles are A, B, D, and E. Now they actually look like squares, but be careful. So I'll take a look at A first. So I look at A, and this is 4 by this here. Now this height was missing. I'm like, all right, well, if this is a vertical height, I look left and right and I see, oh, it matches this height, and this height is also 5. So this is technically a rectangle, right? Because it's 4 by 5. Well, the same thing is for this over here, right? If I take a look, well, this length was missing, but if I look down, oh, it's parallel to this. So this is 5. That means that this is 5, and this height is 4. So D is 5 by 4. So now A and D are exactly the same. E is actually the same too, because it's 4 by up and down. So up and down, if this is 5, I go across, well, this is 5 too. So that's how I know this is 5. So E is the rectangle, the same area. And B also, here's my height. My base going across is from here to here, which matches, if I look right up, here to here. So I have 5 here. So A, B, E, and D all have the same area. Base times height is 4. So I have 4 of them at 4 times 5, which gives me 80, because 4 times 20 is 80. Now, in the center is different. It's not a rectangle, right? In the center, we have going across left to right. If I look here, it was missing, but as soon as I look up, oh, it matches this, which is 4. And then I drop it down here, this height. I go across, oh, it's the same as this height, which is 4. So C is actually a square. Squares follow the same formula as a rectangle because we know a square is actually a rectangle. So base times height, 4 times 4, 16. So our total area here is 96 meters squared. Okay, so just a tad different using dissection instead of area of the larger minus area of the smaller. Next page, what do we have? Okay, another question. Here you will be submitting this answer on your Google form. So again, how do you see this? Is this easy to just do area of the big minus area of the small? Is it easy to just find the area of the shaded figure? Remember to look at these tick marks. I'll give you a little hint. Think about what that means in terms of this entire length being 8. All right, and the last question, here we are. So Kira has a square poster that she is framing and placing on her wall. So she has her poster, that's this here, and then the frame's going around it. The poster has a diagonal of 58 centimeters long, here it is, and that fits exactly inside the frame. So it's inscribed in that frame. The width of the frame around the picture is 4 centimeters. So that means like from here to here is 4 and here to here is 4. Okay, so we have to determine and state the total area of both the poster and the frame. So talking about area here, and it's area of a square. Okay, so in order to find the area of a square, we know we're dealing with base times height. And right now we don't have a base or a height. We just have a diagonal, and we have known that this shaded region around is 4 centimeters wide all around. So what we have to look at is what's given. And what's given is this diagonal. And this diagonal actually divides the square into 2 equal right triangles. So, yep, you guessed right. A right triangle with one diagonal and 2 of the sides that are the same, because it's a square, leads us to Pythagorean Theorem. Here it is. All right, so I took our triangle and I redrew it over here. So we have one leg and then the other leg. That's our A and B. Our hypotenuse opposite the right angle is our C at 58. Substitute that in. Do some algebra. Write x squared plus x squared. Combine like terms gives us 2x squared equals 58 squared is 3,364. Now to get x squared or x by itself, we first have to divide by 2. So we divide by 2. And now we're left with x squared equals 1,682. Take the square root. And remember, it said round to the nearest tenth. That means I can't round this value just yet. I have to round the very end. So the tenth would be here. I'm going to round a few more decimal places out. So I have 49.0122. So what does this length, x, really represent? Let's take a look up here. That represents, essentially, I'm going to kind of do a little bit more. So this x, if I just like kind of draw out here and here, this length from here to here is 41.0122. But I need the length of the entire side of the frame and the poster. So I'm going to add 4, the 41.0122, and 4, because there's 4 centimeters at the top and the bottom. And then this is the total side length of my square. Now, it's a square, so all 4 sides are the same, but I just want to check to be sure that I get the same number on the other side. So let's kind of apply the same thought. So here's x again. Draw my vertical lines down. So x is 41.0122. Here's that little 4 centimeter gap right here, and here's the gap here, and add across, and I'm still going to get the 49.0122. Okay, so all I did was take this and now redraw it to give myself a nice diagram, just for visual, really, for me to explain now. So here's one side, here's the other side. Area of a square, base times height. So we just do our 49.0122 times itself. We get this really long decimal, but we have to round to the nearest tenth. So I'm going to take a look here. Right, that's the tenth. The 9 tells the 1. Oh, you have to go up. So our final answer is approximately 2,402 0.2 centimeters. And that is the final answer. Okay, is that it? Yep, and that's it. So in terms of area of the shaded region, we're just using familiar formulas and kind of formulating a plan of some sort, either breaking a figure up into familiar polygons by dissection, or doing that area of the larger figure minus area of the smaller figure. Don't forget, please submit onto the Google Forms. You're not being graded. I'm just curious to see how you guys are doing out there. Number 4 and also number 1, right? So think, do I want to break these figures up with the shaded region, or do I do area of the larger figure minus area of the smaller figure? Give it a shot, okay? Good luck and stay tuned for tomorrow's lesson.